Welcome to lecture number 3 for ECE476 Advanced Embedded Systems. In this lecture, we're looking at loops, basically for loops, while loops, if statements, all using Python. And again, this is a course offered at North Dakota State University. If you go to Bison Academy under 476, that'll have all the different lectures for this course, the YouTube recordings once they're made, sample code. So some options for you. So what we're looking at in this lecture is using Python. How do you implement for loops, while loops, and if statements? Now, basically, loops are really convenient. They make some codes a whole lot easier to write. This is going to look at how do you do that in Python. Now, a couple things to note. Python is a little bit different than C and MATLAB. In Python does not use end statements. It uses indentation instead. That's different than C. In C, indentation is decorative. It means nothing. Character returns are decorative. They mean nothing. In Python, they actually have meaning. So if I have a loop, like a for loop like this has to indent. That tells Python the following code is part of that for loop. When I break out of it, the for loop is ended. Here's another for loop. This is an example of a nested for loop. I've got a second loop in J. This is indented. Everything at the same level is part of that loop. Now, indentation is important. If I vary the indentation, that confuses Python. The same indentation level means the same part of code. And it really doesn't matter how many lines you indent. So this is 4 spaces. That's the standard in Python. Python doesn't really care. I can indent 1, 2, 3, 4, whatever you want, as long as you're consistent. So indentation is meaningful in Python. And also character returns are meaningful because that tells the next line of code. So that is different than C. So let's start out with a for loop. In Python, the way you do a for loop is you have for, x, in, and one way to do that is like a range function. What range does is it starts from 1, stops when you get to 6. This is sort of like what MATLAB does. In MATLAB, however, you actually execute when you get to 6. In Python, you skip when you're equal to 6. So if I say for x in range of 1 to 6, it'll do 1, 2, 3, 4, 5, and this actually isn't in there. It stops when you get to 6. For example, the as a test is what actually happens. Here I put this in the program window. When I execute it, it goes 1, 2, 3, 4, 5. It doesn't do 6. It doesn't do the right endpoint, unlike MATLAB. So that's a for loop. This executes one time. For the for loop syntax, I have to have a colon. So here's the for loop. You got to have that colon in there. If you take it out, you get an error message. For example, if I do that, take that colon out and try to run it, it says error on line 2, syntax error. You got to have that colon. And the spacing, again, is decorative. Well, 1, 2, 3, or 4. Standard is 4. It accepted 1. Indentation is required. If I take out the indentation, it ain't going to work. For example, if I do this, come on, puppy dog. Try this code. It gives me an error message. You have to have something inside the for loop. This currently has nothing. If I throw in a pass statement, pass is a no-op in Python. Now it's happy, but it didn't actually go through the for loop. This is outside the loop. If I indent it, it's now happy. And you got to be consistent. If I do something like this, it gives me an error message. It interprets that as another loop. It's a different indentation level, and it doesn't know what to do with that. You got to be consistent. Also note that in Python, there are no end statements. The way you tell that the loop is over is the indentation goes back, reverse back to the previous level. So this would be an example of 2 loops that aren't nested. I have x go from range to 1 to 6. When it's done, y goes, x goes 2, 4, 6, 8, and becomes 3 times that. This also illustrates a different way of doing a for loop. If I do a range statement, it counts by 1. If I do something like this, it's just going to go the first element, second, third, fourth. These could be anything. In Python, to do a nested loop, I continue on with the indentation. If I don't indent, this is actually just 2 separate loops. So I execute 6 times, then J executes 4 times. If I do it this way, a for loop followed by another for loop with indentation, then what happens, this is a nested loop. I goes 1 to 3 when I is 1, or D1 is 1, D2 goes 1 or 2. I then go to the next element, D2 goes 1 and 2. So this would be a nested loop in Python. Like I mentioned previously, all for statements have to have something inside that loop. If you don't want anything inside that loop, use a pass statement. A pass is like a no-op. For example, if I count to 100, then 100, then 100, I've actually counted to 1,000,000. If I'm just trying to waste time, I can throw in a pass statement. So I'm going to count to 1,000,000 for no reason other than to waste time. It does work, but there are better ways to waste time. We'll talk about that later. For example, here's that same code. I'm going to count to 1,000,000 for no reason other than to waste time. Until it go, the program started. It's now counting to 1,000,000. Done. Took time, wasted some time. Better ways to do that. In for loops, a common way to go through a for loop is a range statement. When I do range of 0 to 5, it starts at 0, counts by 1, and stops when you're greater than or equal to 5. Again, a little bit different than C. In C, I stop when I'm greater than 5. In Python, I stop when I'm greater than or equal to 5. So for example, if I say for I in range of 0 to 5, it actually counts 0 to 4. If I wanted to go to 5, what I could do is to go from 0 to 5.01. So now as soon as I'm equal to or greater than 5.01, I kick out. So 5's okay, 6 I kicked out. I could add a third number into a range statement. That gives me the step size. So if when it goes 0 to 10, steps of 2, I would do 0, 10.1, because I want to stop at 10, steps of 2. When I do that, I is going to go 0, 2, 4, 6, 8, 10. As I go through the loop, it executes this one by one. So when I is equal to 0, 0 squared is 0. When I is equal to 2, 2 squared is 4, and so on. That'd be a step size. You can also step through an array. For example, suppose I want to find the square of prime numbers. Well, an easy way to do that is to define a variable called prime. That's the prime numbers from 1 through 11. That's 1, 2, 3, 5, 7, 11. For I in prime, this is going to go from the first element, 1, 2, 3, and keep on going one by one. Print I, and then, well, print the element and then the square of it. So as we go through, it'll go 1, 2, 3, 5, 7, 11. One of the uses of for loops. With for loops, I can do exhaustive searches. So if you recall back from 376, that's the prerequisite for this class. Again, you really don't have to have it, but one of the problems we had in 376 was setting up a timer to interrupt. If I want to produce a frequency like 327 Hertz, I need to come up with A times B times C, which is close to this frequency. The target that I'm looking for is 10 million divided by 2 times Hertz. Find A, B, and C that's close to that, subject to the constraint that A is 1 to 316, B is 1 through 256, and C is 1, 4, 16. So what combination is best? Well, I can do that in Python. That'd be nested for loops. So A goes 1 through 16. So it's going to go 1 to 17. 17 means 16 because you don't do the last element. B is 1 through 256. C is 1, 4, or 16. When I do that, I'm going to sit there and calculate what is my target. Here's my frequency. The number of clocks that I want is 10 million divided by 2 times hertz. Again, you can throw in these underscores for 10 million, makes it easier to read, not necessary. There's the target that I want for n. I want A times B times C to be 15261.12. I can't get that exactly. What's the closest I can do? Well, I'm going to start out with the min error being 99999, something big. Go through every combination of A, B, and C. Calculate A times B times C. Is that error, find the error between my target and the result. If the error is smaller than my previous minimum error, copy A, B, and C. Copy over the new minimum error and repeat. Unwind 3 loops, and eventually when I'm done, print out what is A, B, C, and N. So when I do that, here's my target. The best I can do is 6 times 159 times 16, and here's the resulting N. So this shows off some of the nice features of Python. I can see the loops very easily. And I can sit there and try it. If I want to get 327.63 hertz, here's my target N. That's the best I could do. Let's try something else. Let's try 220 hertz. That'd be middle C. Target is 22727.27. That's the best I can do. 22720, and the combination of A, B, and C, the best you can do. So that's a for loop. Another thing you can do with for loops, I can create arrays. So let's come up with a 4-sided die and a 6-sided die, come up with a PDF for those two. Now for 4-sided die, the probability that I'm going to roll the numbers 0 through 10 are as follows. I'll never roll a 0, never get a number 5 or bigger. I just have numbers between 1 and 4, and each with equal likelihood. For a 6-sided die, I get the numbers 1 through 6, each with equal likelihood. And the sum has to add up to 1 to be a valid probability function. So that's what the PDF looks like in table form. Here's what it looks like on a bar graph. Let's input those two probabilities. Well, one way is using no finesse. Just say D4 is, here's the chance I'm going to get a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Likewise for D6. That works. I could use a for loop. I'm going to start out with having a 0 matrix repeated 10 times. Again, what this means is in MATLAB that'd be 10 times 0. In Python, what that means is I'm going to have the matrix 0, or string 0, copied 10 times. So kind of like here. I can grab that. To say x equals 0, there's x. D4 is 10 times x. That's 10 copies of x. Again, MATLAB is a little bit different than Python. I'll then fill in the array for k in range of 1 to 4, including the last endpoint. Each element should be 1/4. For the 6-sided die, for the numbers between 1 and 6, I should have a probability of 1/6. If I do that, I get the same answer. Third approach, I can use the subroutine. That'll be a later lecture, so we're not going to worry about that right now. If I want to format the output, I can do this. I can use the format command. Those will be fixed decimal places, 3 digits, no decimal points, 5 digits, 3 decimal points, 5 digits, 3 decimal points. And when I run it, so you can see it, here is k, the result of the die roll, 0 through 9. I've got a 25% chance of getting numbers 1 through 4 on the 4-sided die, 1/6 chance to get the numbers 1 through 6 on a 6-sided die. So that's the for loop. I can do while loops. With a while loop, I keep on going over and over until a condition is satisfied or until I hit a break statement. For example, suppose I want to find the probability of flipping a coin k times until I get a heads. That is an exponential distribution where the probability of k tosses being 1/2 times 1/2 to the k minus 1 u of k minus 1. So the probability I'll get a heads on 0 tosses is 0, half a chance, 50% chance in 1 toss, 25 in 2 tosses, 1/8 in 3 tosses, 1/16, and so on. I could calculate that with a for loop. So suppose one just display it out to 10. And this is an infinite series, so we can't really go to infinity. Let's just stop at 10. So with a for loop, I'm just going to go from 1 to 11 and append k to the end of 0, append onto p, 0.5 times 0.5 to the I minus 1. I'll then print what is k and p of k. So here is k formatted as 3 digits, no decimal points. P of k as 5 digits, or 6 decimal, with 3 decimal points. So when I do that, I get, here's your k, and the probability of that many tosses. So there's a 6.3% chance it'll take me 4 tosses until I get a heads. I could use a while loop instead. So let's keep on flipping until the probability is less than 0.01. So in that case, I'm going to have initially starting at 0.5, k is 0. Keep on going as long as x is bigger than 0.01. As I keep on going, k goes up by 1. That's the number of tosses. X becomes 0.5 times 0.5 to the k minus 1, and append that to the end of the previous array. When I'm done, I'm going to print out the array, so go from 0 to the length, displaying the data k and the probability. And it looks like after 7 tosses, the probability was less than 0.01. That's a while loop. Keep on going until the condition is no longer satisfied, until x, or keep going while x is bigger than 0.01. Another common use of a while statement is to set up an infinite loop. So this is oftentimes run like if I build a stoplight. I want the stoplight to work over and over again. I don't want it to work just once and then have to buy a new stoplight. To do that, I can do while true or while 1. Again, 0 is false, anything non-zero is true, so while 1 works. This says forever and ever and ever. I'm going to go through this loop. I'm going to wait for you to input a number. When I do that, calculate the square, then come back, wait for another number. Calculate the square, then go back, calculate another number. This goes on and on and on. To break out, I'll hit the stop. So let's show that in action. This is an infinite loop. When I run it, it's going to ask for my number x. Let's do 7. 7 squared is 49. Let's do 4. 4 squared is 16. 13. 13 squared is 169. 72 squared is 5184. It's going to go over and over and over. To get it to stop, I'll hit the stop statement. That broke out of the loop. Hit it again. That clears out the screen. And I'm ready to run a new program. That's a for loop, or while loop. An if statement. An if statement executes a set of commands if the statement is true. The type of commands you can get are x greater than y, x less than y, greater than or equal to. So double equals is compare, single equals is assign, just like C. Not equals, there's also and, or, exclusive or. Indentation is important. You have to have something after each command. I can say if x is greater than y, then print x is greater than y. So these are 3 different if statements. It'll check each one by one. If they're true, I'll do the following line of code. For example, if I say x is 2, y is 3, run it, it's going to check each line one by one. X is not greater than y, skip. X is less than y, I print that. x is not equal to y, skips. Make these the same, then the third one is true, x is equal to y. If x is bigger than y, the first one's true. So that's your 3 if statements. There's also an else statement. I can do if x is greater than y, I'll do the following. If that fails, then the else statement is kicked in. If the first one is true, then I skip the else statement. You can also do else if. In Python that's spelled ELIF, else if. So if x is greater than y, I'll print else if x is less than y, else x is equal to y. Actually, that part doesn't belong. So one place where else if statements are useful is if you have different bands. For example, if I want to say, based upon the temperature, I want to say, is it really, really hot, comfortable, or cool? I could do a bunch of if statements. If t is greater than 40, it's really hot. If t is between 30 and 40, it's just hot. Between 20 and 30, comfortable. 10 and 20, cool. That's one way to do it. Another way is with the else if. If I say if temperature is greater than 40, I'll have this one, else if. If I hit this line of code, that means the first one failed. So it's not greater than 40, but greater than 30. This is the middle range. If that fails, it's not greater than 30 and not greater than 40. If it's also greater than 20, that tells you between 20 and 30. Between 10 and 20, less than 10. So that's kind of a use of the else if statement. I can kind of go through the different bands. With if statements, I can do PDF functions. It's a more efficient way of creating the 4-sided and 6-sided die. So we can start out with D4 and D6 being an empty matrix, and then do a for loop for k in the range of 0 through 8. If k is between 1 and 4, I'll append a 1/4, otherwise append a 0. So for a 4-sided die, I can get the numbers between 1 and 4, there's the probability. For the 6-sided die, for the numbers between 1 and 6, those are valid possibilities. Each has a probability 1/6, otherwise a 0. If I do that with a for loop and if-else statement, I see here's my 4-sided die, there's my 6-sided die. Another way to generate the probability of rolling a number on a 4-sided die than 6-sided die. This is a little bit more efficient. Finally, what I can do with if statements, I can do convolution. So suppose I want to know what's the probability of rolling a number or a sum of 4-sided die and 6-sided die. That's actually convolution. You take the PDF for the 4-sided die and convolve it with a 6-sided die. In terms of coding, what I do is I take the 4-sided die, first create the PDF for the 4-sided die, create the PDF for the 6-sided die. So that's just the PDFs. This is the convolution loop. I'm going to convolve the 4-sided die, x of k, with y of n minus k. There's the convolution. And that's only true if I'm between the left endpoint and right endpoint. So this is a program to do convolution. Yeah, basically what you do is take your 4-sided die, 0, 1/4, 1/4, 1/4, 1/4, 0, 0, 0, 0. Convolve with a 6-sided die. When you do that, you flip the 6-sided die. Gives you 0, 1/6, 1/6, 1/6, and you sweep that right. Multiply together and add. So this is the multiply together, then add. The total will be the probability of rolling the number k. If I look at what k is, I get this. That's the probability of rolling the different numbers. So there's no chance of getting a 0, no chance of getting a 1. There's a chance of getting a 2 for summing a 4 and 6-sided die. 3, 4, 5, 6, 7, 8, 9, 10. That's convolution. And that's one way to do that are for loops. So that's kind of some of the looping you can do in Python. MicroPython is very similar to MATLAB. You've got for loops, you've got while loops, you have if statements. The syntax is a little bit different than what it is in MATLAB. MicroPython doesn't have an end statement. Instead, it has indentation. And the indentation is important. It tells you what statements are part of a loop. It also tells you where the loop ends. That's different than C. In C, indentation is decorative. In Python, it's very important. In C, you also have end statements. In Python, you don't need them. It just uses indentation. So with that, you have access to for loops, while loops, and if statements. And that's lecture number 3 for ECE476.